Hello, in this lecture we want to talk about limits and continuity. You'll find this in section 14.2 in your textbook. From the title, we're going to talk about the limit of a function and the continuity, the region at which the function is continuous. So now we're dealing with functions of more than one variable, like we discussed last lecture. We have two independent variables, or we could do with more variables. Yani you could have a function with three independent variables and so on. If anything we're going to talk about, we are talking about functions of more than one variable. We will need to find the limits and discuss the continuity. Now let's recall from the calculus, previous calculus of one variable. When you had a function y which is equal to f of x, you define the limits to be the limits of the function f of x as x approaches a point A, and the limiting value we called it L. Okay, this is the notation that we used before. So let's discuss a little bit this issue before proceeding. Or alternatively, I could write it like this. It is the limit that there exists a small value delta and epsilon such that x minus a greater than 0 less than delta. Then I'll have the absolute f of x minus l less than epsilon. I want to discuss these two notations using this simple example. Say we have this example, y is equal to x squared minus 1 over x minus 1, where x is not equal to 1. This is the function defined, and the domain here is the whole real number line without the x is equal to 1. Type. Now if I want to find the limit of this function f of x as x tends to 1, then I write the notation like this. This is the form that I write it. If I need to find this limiting value, when I do substitution, as we usually did here, I'll obtain 0 over 0, which is so this is an undefined quantity. Okay, so I need to do some more job to find a value for this limit. Type. If I did some factorization and simplified this, I'll obtain the function will be simplified to x plus 1. Okay, now I need to take the limits, but when I substitute with the limiting value, actually I'll reach the value 2. But when I substitute x is equal to 1 in this formula, then expression I'll get a 2. But we call this 2, we call it actually the limiting value of the function f of x. Okay, so what does this mean? Geometrically, what does this mean? This means that I have a function, and this function I want to approach x is equal to 1. Now I understand when I approach x is equal to 1 with my function del x-axis, and this is my y-axis. Okay, actually I arrived at the value 2. Whatever this function actually might look something like this. Okay, this is actually this straight line. So now what does it mean? Take the limit as x equal 1. Actually it means that if I'm standing at any x close to 1, okay, either from the left or from the side, and I approach the point x is equal to 1, this from the right, and I'll approach from the left, I'll approach from the right, actually as if I'm coming from a distance delta from the point x is equal to 1, as if I'm coming from here, where for which the point here is x, for any x, okay, minus 1 is less than delta, or here like from this one x minus 1 is greater than is less than delta. Okay, either I'm approaching from the left or I'm approaching from the right. Yeah, but this is actually as if it's from within 1 minus delta, as if I'm approaching from within 1 plus delta. Okay, so I write it like this: x minus 1, as if I'm centered at the 1, and I'm approaching from any value where the distance is less than delta. Okay. Okay, so this is the notation that we use. This we understood that I'm approaching from here. The notation actually usually used was a minus and a plus. When we say a minus, it means that I'm approaching from a point x minus delta. When I'm talking about a plus, as if I'm moving from a minus delta, sorry, when I'm approaching for a plus delta. Okay, يبقى ده what we mean by a minus and a plus. يبقى I have هنا two possible directions from which I can approach the point a, x is equal to a. Two possible directions from which I can approach the point x tends to a. Either I'm coming from a minus, or I'm coming from a plus, يعني a minus delta or a plus delta. Now what's happening back to the range of the function? But the range of the function, when I'm approaching from here or here, actually the range should be also bounded by this epsilon. I should have the range بتاعي اللي هو y minus L for any value. It must be within epsilon. I need that برضو ده is, if this is centered at the L, then I need it to be moving within epsilon. Let's go back to the definition. I say that the limit exists if this is defined, x minus a lying within delta, then the function f of x minus L will lie within range epsilon. Okay. This actually can be occurred for such examples. If I have an example defined as a piecewise continuous function, and the function say مثلا like this, x plus 1 here x, and this is defined for x greater than or equal 0, and x is less than خلينا نبتدي x less than 0. يبقى from negative infinity to 0, but then from 0 to infinity. Now I need to find the limit of this piecewise function as x approaches the point 0. Now I need to check all directions. If I did a sketch, it's obvious that the limit does not exist, and for values of x less than 0 I have this straight line. For values of x greater than 0 I have this line. So obviously, and x is equal to 0, actually I won't have a limit. Then هنا actually it's obvious it will go to 1, and here obviously will go to 1. How do we mathematically write this? Actually we write it like this. I'm gonna approach from 0 minus, from before the point 0 of the function, then I'm gonna substitute with the first part of the function, lower x plus 1. I'll end up with 0 plus 1, which is equal to 1. What is this? This is the limit from the left hand side. But when I want to approach from the other direction, which is 0 plus, I'm coming from approaching from the right, any place here for x from the right within epsilon, then I'm gonna say take the other part of the function, which is y equal x, I'll substitute in x by d 0. What is this? Actually this is another value for the limit. بالتالي the limit as x tends to 0 turned out to have either 1 or a 0, then where limit 1 definitely is not equal to limit 2. Then I can conclude directly for my problem that the limit x tends to 0, f of x actually does not exist. But the limit does not exist. We abbreviate it like this. Okay. But the limit of this function f of x does not have a limiting value. I approached all direction and I found a value. Other examples that doesn't have a limit, if I don't obtain a real number, say مثلا like this example, f of x is equal to 1 over, let's say, x minus 1. Actually, x is not equal to 1. This is not in the domain. But what if I want the limit for the function f of x as x approaches 1? Actually, the limit of x approaches 1, I do 1 over 0 to approach the point x equal a. Now let's go back for functions of more than one variable and see what is the case now. Still, I need the limit of the function f of x as my xy approaches a point, this time a and b, where x is equal to a, b and y is equal to x is equal to a and y is equal to b. And the limiting value will be, the notation is the same. I have the limit of the function f x y. I put my point approaches a b, and I'll have this limit L. Also, the equivalent form of the limit is these equations. We want to understand what's going on here. يبقى ده an equivalent that I want to approach the point from any distance delta from my point, right? And the range of the function will lie within this range epsilon. It is the same. يبقى let's say بقى we are talking about a limit of a function. Okay, if I'm approaching from any point xy to the point AB. When I'm talking here, we're talking about the xy plane. My point will lie in the xy plane. We have more than one variable. We deal with R2. يبقى في ال xy plane, I'll plot my point AB. And I'm telling you, I want to approach this point from any direction. How many directions do I have? It's obvious from this figure. How many directions do I have? I'm approaching from any distance delta, and I have a distance delta here, and I can come from any point within this within the radius of this circle, radius delta, centered at point AB. Got the idea? And if you're standing here at point AB, and I told you I'm standing at any point xy such that the distance from the point to the xy to the center AB is less than delta. You'll tell me I can arrive from any point within the circle that is centered at AB and has radius delta. Tab this for the x. So we have in this formula, this is actually equation of the distance from the point xy to the point AB. It's actually equation of a circle centered at AB and has radius delta squared, delta. Okay. Type. What about the range of the function? What will happen? Any point you substitute xy for the function f of x, actually, if the limiting value is L, then if you have a range of the values within this epsilon, then the limit will exist. Okay, so this is the same. The only difference is that I say I approach from infinity. I approach the point from infinity direction, from any point on this circle, infinity direction. For one variable, I have only two directions. I can come from the left and I can come from the right, from A minus to A plus. And I cannot say A minus to B minus because I could come from any direction along a line yanis inclined بالشكل ده to the point AB. Okay. طيب خلاص, we understood now that the limit exists if I approach from any direction, and these directions actually could be any point within a circle. That's it. Okay, we'll do the same job, same rules will apply with us. Let's do some simple examples. This is about the three-dimensional figure that describes the limiting that I'm moving in the neighborhood of the point AB within this circle or disk with radius delta. The range of values will change within epsilon around the limiting value n. Okay, the examples bar. If I do simple substitution like we did before for this problem, I want the limit as the xy tends from 1 to -1 of this function. All I have to do is substitute simply with the values of x and y. So I'll end up with e to the power -x, y is a -1 phi times cosine 1 minus 1. Okay, يبقى بالتالي I substituted with the point 1 and -1 in my function. Then I have a real number which is equal to e times cosine 0, which is a 1 and e. يبقى I have a real number, finite value كده, and this value actually is my limiting value. But the limit of this function actually is equal to the exponential or 2.71 and so on. Okay, but now we have a real value for the limit. Do I need to check paths? Do I need to check all direction? As long as I arrived at a real number, real value, then this will be my limiting value. Whatever, definitely any direction, this will have the same value. So if I have function like this and I did simple substitution, I need here to get the limit at the point 0, 0. So I'll substitute with the point 0. Then I end up with with 0 over 0 over 0. Then this value actually is undefined. This is not a real number. I don't have a conclusion yet, so I have to do something. Actually, the first thing that should come to your mind is simplify. Can I simplify more to find a real number? Let's try. Definitely here I can do some factorization. I'll end up with x squared minus y squared over x squared plus y squared. They will cancel out with each other. Then I'll end up with a simpler formula for the function, which is equal to x squared minus y squared. Now after simplifying, I can take the limits. Now the limits is xy as xy يعني approaches the point 0 0. Yeah, but actually by simple substitution now I'll end up with a 0. Now I arrived at a value finite real number, then this is my limiting value. Yeah, but this function actually turned out has to have a limit as x tends to 0, y tends to 0 0, and this value actually is equal to 0. Okay, so the cases that need some job to do, such as this one. If I want to do substitution, I'll end up with 0 as a 0. Actually, there is no simple factorization or no more simplification for this problem. I have in the above 6x cubed y over 2x power 4y. How can I conclude that this has a limiting value? Actually, I'll need to do paths. Why? I need to check if the limit along different paths will give me same value. But the objective here, the objective of such problems, when I'm not able to find directly a conclusion, then I'll go with the approach the point. Our point here in this problem is 0 0. I need to approach 0 0, okay, from different paths. Okay, this is my objective. But why do I want to do this? Actually, I want to do this to be able, if the limits along different paths are different, then definitely I won't have a limit. Okay, then this will be conclusive. Okay, so what paths I could take? Actually, there is infinite paths. I could select usually the simplest or the direct paths that I could move, say, مثلا along the x-axis. Yani as if I'm approaching the point 0 0 along the x-axis, yani as if the variable y is equal to 0. Okay, then I can substitute in the function expression of the limit and get a value. Okay, this is not the limiting value because I don't know if I changed path, say I took another path like the y-axis, that is x is a 0, and it could have different values. If they have different values, then I'll stop and say then I have a conclusion and the limit does not exist. Okay, now if another path, well, I'll take the more general path, which is equals to mx, where m is the slope of definitely this passes through the 0 0, where m is a real number, and this is the slope of the line that passes through the origin. Okay, so this is another path and so on. When do I stop? I stop when one of the limits are turned out to be equal, not to equal, or the limit turned out to be function of a slope. And the function of a slope معناها when I change the slope I'll end up with a different value. Okay, as we'll see from this example. Okay, so what if I've done the jobs along different paths and I'll end up with equal and same limits? What if the limit in all directions is the same? Do we guarantee all directions? I mean here the selected directions, actually, and to be very specific. Yeah, the selected directions you've done, if the limit is the same, can we guarantee existence? Actually, we cannot guarantee existence. Okay, because I cannot consider infinite directions. Okay, I cannot consider infinite directions. بالتالي I have no guarantee these simple paths that I took, if they are equal, then I have existence. Okay, then I cannot guarantee a limit exists. Okay, then we have another method, we'll take it in a while. we call it the polar or more general method. Okay, طبعا there are different other paths يعني we could select any other paths برضو and try them. If you find inequality and they are not unequal, then they are then definitely you have a conclusion. Let's do a problem بقى. يبقى 6x cubed over 2x power 4 over 2x power 4 plus y power 4, and I need to find the limit as x tends to y tends to 0 0. So let's do the job. On no simplification, 0 over 0 undefined, then we have to do paths. Then I'll apply paths method, and let's select the first path along the x-axis, then I'll take my y equals 0. Okay, so when I substitute y is equal to 0, I'll end up with 6x cubed y for 0, which is a 0 definitely, over a 2x to the power 4. Now I ended up with a function in only one variable, so this limit, by substituting y equals 0, I ended up with a limit in one variable x. And before continuing here, I should note or remark that I should simplify first and then substitute with the limit. You should always simplify first. Put under this a كذا line. And if I didn't simplify first, I will end up with 0 over 0, which is undefined, and I'm stuck. I didn't get a conclusion. I need to find a conclusion. So when I simplify 0 over anything, this is still not, this is for any variable x, but 0 over x is a 0. Now I didn't even need to take the limits, okay? So I have a value for the limit, and this value is equal to 0. Now this, I cannot conclude that this is the limit of the function. This is the limit specifically along the x-axis. Then I'll have to do another job, take another path, say مثلا along the y-axis, let's x is equal to 0. Then I'll end up with limit 0 over, I'm substituting for the function, but let x is 0, I'll have 0 over y to the power 4. Now this is a limit in variable y. Let's do the job, simplify first, I'll have the 0. There is another value. Can I conclude now? And we discussed this before, but let's ask again. Can I conclude, since L1 is equal L2, that a limit is equal to 0, that the L of the function is equal to 0? This is what I'm looking for. Does there exist a limit? Actually, no, I cannot conclude. Not necessarily, as if only two are along two paths or limits are equal, but it's not necessarily that the limit will be these limits. Okay, it's not necessarily. So I have to continue on. Let's take a more general path. Let's take the line y equals mx that passes through the point. Definitely I need to take a line that passes through my point of the limits. يبقى بالتالي I'll take this where m is the slope. Let's substitute. يبقى بالتالي the problem will be limit 6x cubed y is equal to mx over 2x to the power 4 plus y power 4, which is m power 4 x power 4. Okay, but I substituted every y in the function with mx. Now take the limits as xy tends to 0. Should I write here xy? I don't have, I'm take care here. We're only dealing with now I transform the problem to only one variable, which is an x, so it doesn't have any meaning to put xy here. I put only the x tends to 0. Okay, now do the job. Tani, so I'm stressing, simplify first, because you don't do this actually in the exam. Simplify first, then take the limits. Okay, so when I simplify, actually I'll have x to the power 4 will be cancelled out from the problem. I'm ended up with 6m over 2 plus m to the power 4. I still didn't take the limits. X tends to 0. So now it turned out that x has been cancelled out. I don't have even an x if I have anything to substitute with, I'll end up with this same value, 6m over 2 plus m to the power 4. Got it? What is this? Actually, for every m, for every slope m, we will have a different limiting value. We will have a different limits. That is, the limit turned out to be a function of m, then the limit definitely I can conclude that the limit does not exist. The limit is different from different directions. When I change the slope, I find a different value of the limit. Got the idea? Okay. If it turned out to be a value independent of m, still I cannot actually guarantee, so I'll have to do the next case. Okay.